Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject code ME8791, title Mechatronics, unit number 2, myself Saravanan, assistant professor in the Mechatronics department. So this is the course objective and outcome of Mechatronics, syllabus for Mechatronics, then textbooks and the reference unit 2. So last 3 chapters we discussed about architecture of 8085, pin diagram of 8085, addressing modes and instruction sets. Okay, these are the basic concepts of 8085. So that is when we go for programming 8085, we need to know the basic architecture of 8085. That means um, we can uh, we can know. So what are the internal functional diagram of 8085 like that? We can learn from the 8085 architecture. Then pin diagram. So this is for output connection. We need to know the pin diagram for external input output devices or external device control like that. We need to know pin diagram. For programming purpose, we need to know addressing modes and instruction set. Then only we know that different kind of instruction set as well as different kind of operands they are using. Okay. So next one is timing diagram. So why we go for timing diagram of 8085? This is it is the image representation, or it is a graph representation of 8085 instruction execution. Okay, so already we discussed that we have a lot of instructions in, that is 246 instructions in 8085. Okay, which type of instruction we need to use for a particular program we need to know, because for addition program we can write with 4 instructions, as also we can write with 100 instruction for addition program. Okay, this is the concept. So we need to use minimum number of instruction in the particular program. So we need to know the T state, that is timing state like that they call. So timing state, that means for one instruction execution for one time cycle, that is T state. Okay, like that we are going to discuss. For one instruction, for example, move A comma B going to execute. Okay, how many time cycles it will record. So that is the concept of time diagram. It is a picture representation to know about the, so where we are read the data, where we are write the data, then how many clock pulses required to execute the instruction like that. Because uh, at the same time we can use move and add. Okay, but if you're using which one is best like that, we can done by the timing diagram. That is a total of how many T states required to execute like that, we are going to calculate in the timing diagram of 8085. Let's see one by one. This is the 8085 architecture. Pin diagrams, addressing modes, different kind of addressing modes. So we discussed with a particular examples. This is the instruction set. Last class we discussed. There are different kind of instruction group. (8085) timing diagram. A timing diagram is a graphical representation. It is represent the execution time taken by each instruction in a graphical format. The execution time is represented in T states. So this is the concept. So here we need to know 3 cycles. That is an instruction cycle, the time required to execute the instruction. For a particular instruction, time required to execute the instruction called instruction cycle. Measured cycle means the time required to access the memory or input output device. The time required to access the memory or input output device. That is already we discussed memory read, memory write, input output read, input output write. That is called machine cycle. Got it? That is, in memory we are going to read and write. There are two operations: memory read and memory write. In our external input output device, we are going to read and write. So that is input output read and input output write. These are the machine cycle. So as well as opcode fetch. Okay, that is we are getting the opcode from the memory only. So that is the concept of opcode fetch. It is also one type of machine cycle. Next, T state. The machine cycle and instruction cycle takes multiple clock periods. A portion of operation carried out in one system clock pulse is called T state. Because the machine cycle work in uh, one machine cycle required three states. Like that, it will require to execute using three clock pulses. Okay, that is one clock pulse is called T state. So this is the time period and the frequency concept. So this is the clock pulse. So this is the one state, one on, one off, one on clock pulse. So that is the one state. Okay, for a particular machine cycle, it will require three machines, three T state or four T state like that. Okay. So using frequency, we can define the time period because most of the processor having 5 megahertz, 10 megahertz like that. Okay, so time period T is equal to 1 divided by 5 megahertz. So that is differ 20 millisecond or 20 microseconds will be like that for execution of the one T state. Okay, this is define the speed of instruction execution. So nowadays CPUs are working at 2.5 gigahertz. Okay, you imagine T is equal to 1 divided by that is T is equal to 1 divided by 2.5 gigahertz means it will work in the nanoseconds. Okay, so only nowadays systems are very fast and accuracy. So timing diagram, this is 7 basic machine cycles. So already we discussed in the last topic, that is machine cycles. So first one is opcode fetch cycle. It is required 40 or 60. T means T state. Then memory read, memory write, input output read, input output write, interrupt acknowledgement cycle. Then bus ideal cycle. Okay, so memory read, memory write, input output read, input output write. They required three states. Sorry, three T state. Interrupt acknowledgement required 60 or 12 T state. So this is the concept of selecting the which machine cycle we are going to use. Okay, already we discussed. That is IOM. So IOM define the which location we are going to access. Whether we are going to access the memory or whether we are going to access the input output device. So if you want to access the memory means you have to put 0. If you want to access the input output means you have to put 1. Okay, same as here S1 and S0. If both the values are 0 and 1 means it is right. 1 and 0 means it is read. 0 and 1 means right. 1 and 0 means read. So this is the concept. If both the values are 1, that is opcode fetch with respect to the memory. Okay, because all the instructions opcode will store in the memory only. So we are selecting the memory. If both the values are 1, it will define the opcode fetch. Then interrupt acknowledgement. If in the input output devices we can get the interrupt value. So S1 and S0 value 1 means it will be interrupt acknowledgement concept. So here all the values, all the control signals are working here active low signal. That means if these values are 0, out the control signal will be enabled. That is RD bar is equal to 0 means read process will be defined. WR is equal to 0 means write process will be defined. So this is the example of opcode fetch cycle. That is 4 T state. That is T state 1, 2, 3, 4. That is each clock pulse, low and high, low and high. So this is the general format of describe the timing cycle. Describe the timing cycle, that is timing diagram. First you have to write the clock. Then so clock already we know that if you are using 12 T statement, you have to use 12 clock pulses. Then address, higher order address. Okay, higher order address like that they are defining. Then lower order address maximum it will be in multiplexer, that is 80 to 87. that is shown like this. That is ALE. So ALE should enable because it is active high. When 1, it will be enabled. So every clock pulse started, that is every machine cycle started, the ALB should be enabled. Okay, for example, this is the opcode fetch. If you are adding extra read means you have to read the concept, the latch will be enabled. That is ALE will be enabled for the every machine cycle. Then this is the condition. This condition written from the previous table. Okay, opcode fetch means what we did, that is we need to select the memory, then we need to define the S1 and S0 value. So we need to select the memory means we have to put 0.